Okay, so in this video we are going to talk about the infinite limits. Okay, so for infinite limit means the limit will be infinity. So you will plug in a finite number for x, but you will get infinity for the limit. Okay, we'll talk about that. Okay, so what is the definition? Let fx be a real valued function defined at each point of an interval I containing c. Suppose there is an interval that has c, but the function is defined at each of the point in that interval, but it may not be defined at c. That is fine. If limit x tends to c minus fx, if the left limit, okay, and the right limit are both either positive infinity or both negative infinity, then we say that the limit of that function is positive infinity or negative infinity. So in this case we call this is infinite limit, okay, because we got that infinity. This is also infinite limit. Either case it is infinite limit. But sometimes you get the left limit is positive infinity and the right limit is negative infinity. If you get different infinities, then we say the limit does not exist. Otherwise, if you get the same infinity, positive infinity or negative infinity both from left and right, then we say that the limit is infinity. Okay, so let us talk about some of the facts. So c over 0, if there is a non-zero number divided by 0, that is infinity. And if there is a non-zero number, negative non-zero number divided by 0, that will be negative infinity. Okay, and if one of the left limit or the right limit is infinity, if left limit is infinity or the right limit is infinity, or this is one of those, okay, then x equals to c is called the vertical asymptote. Okay, you saw the vertical asymptote in the in college algebra, right? Vertical asymptote is, you see that what was the scenario of the vertical asymptote? There was a vertical asymptote, right? The graph will be look like this or either look like this. You see that here both of the left limit and the right limit are negative infinity, or you can have both of the left limit and the right limit are positive infinity there, right? So in this case we call that x equals to c is called the vertical asymptote. Okay, so this is the definition of the vertical asymptote in the limit sense. Okay, if x equals to c is a vertical asymptote, then there are two cases. What are those two cases? One is either the left hand limit and the right hand limit both are infinity or positive infinity, we call the infinite limit. Or if the another case is left limit and the right limit are different. They are infinity but different type of infinity. One is positive infinity, other is negative infinity. In this case, no infinite limit. So we'll see some examples related to this. Let us see this one. Limit x tends to negative 2 fx for fx equals to 1 over x plus 2. So let's do this problem, okay? So we have limit x tends to negative. Let's find out, to find out the limit, let's find out if you plug in directly here first. If you plug in directly, you will get 1 over, you get negative 2 plus 2, 1 over 0. You will get positive infinity if you plug in directly, right? But we want to check by taking the left limit and right limit and then see whether it is really positive infinity or not. Okay, so let us take the the left limit for 1 over x plus 2. What do you get? You are taking you are going to negative infinity from left, right? You see that you are going to negative infinity from left. So you will get, for example, you will get negative 2.1, negative 2.01, negative 2.001, like that, right? Because there is negative 2. You are going to negative 2 from the left, negative 2.5, negative 2.4, negative 2.3, negative 2.1, negative 2.01, negative 2.001, and so on. In that case, that x value will be bigger than 2. You understand that? Bigger than 2, but that is in the negative sign, right? So you will get a negative number on the denominator actually. Whenever you take these values close to negative 2, you will get a negative number. So it will be like negative 1 over 0 format. You see that? Because this number, you are taking x values close to negative 2. You are taking x values close to negative 2, but you are going to negative 2 from left. So when you find the difference, you will get negative number all the time. So let me move that negative number on the top. But when you get very, 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 very close to negative 2, at that time you will get the difference of x and 2 is almost 0. So basically this value is negative infinity. How about the right limit? Limit x tends to negative 2 plus 1 over x plus 2. Basically we are going to x plus 2 from the right side, right? Negative 1, negative 1.5, negative 1.6, negative 1.9, 1.99, 1.999 and so on. In that case, you will get this number positive, right? Because when you take x is a number very close to negative 2, but from the right hand side, this value will be positive, right? So but when you get very close to negative 2 for this x, then you get 1 over almost 0. That will be negative 1.9, negative 1.99, negative 1.999, like that. It will get almost 0, but 1 over almost 0 will be positive infinity. You see that? When you go to negative 2 from left, you get negative infinity. When you go to from the right, you will get positive infinity. So the left limit and the right limit are not equal. So the limit does not exist. So no infinite limit. No. Let me use different color there. So no infinite limit. No infinite limit. Again, when you go from the left side, you will get negative number all the time. And then when you get very close to negative 2, this will be almost 0, but negative from negative side, right? So it will be negative 1 over almost 0. But when you go from right side, this 2 will be bigger than x all the time. You see that? So when you get very close to negative 2, it will be 2 and then minus almost negative 2. 2 plus almost negative 2. That will be 0, but positive, okay? That will be infinity. So the left limit and the right limit are not equal. So the no infinite limit exists there. Okay. How about this one? Let's go to 7 from left. Limit x tends to 7 from left, 1 over x minus 7 square. So what I'm trying to do here is I'm going to 7 from the left, like 6.9, 6.99, 6.999, 6.9999 and so on, right? You're going to 7 from the left, from this side. You see that? In that case, but since there is a square, even though you will get negative number when you go from the left, the difference will be negative 6.9, 6.99, 6.999. The difference will be negative, but squaring will be positive. So you'll get 1 over 0. So that is infinity. But when you go from the right, limit x tends to 7 plus 1 over x minus 7 square. You are going from the right side. So how does that look like? 7.5, 7.4, 7.3, 7.1, 7.1, 001, 7.0001. In that case, the difference will be positive, right? So square of the positive is again positive. So it will be 1 over 0. That will look like again infinity. So you see that from either side, you got the values infinity, right? So left limit is infinity, right limit is also positive infinity. Both are positive infinity. So you can write limit x tends to 7, f of x is positive infinity. So this is the case of infinite limit. You see that? Both of them will look like this. This is 7 there. So from the left, it is going to positive infinity. From the right, it is going to positive infinity. But in the previous case, you got from the left, you get negative infinity. It look like this. From the right, you got positive infinity. Look like this. Okay. So they are not the same infinity. Okay. So you got the different infinity. So the infinite limit does not exist. Here, the infinite limit exists. So how about this one? Let's look at the left limit. Oh, this is you are asked to find out the left limit, right? So what you do, you plug in the negative 6 square, that is 36, right? And you write down the negative 6 from the left side. You will, from the left side, you will get this difference will be negative, right? Because see, you are going to negative 6 from the left side. So it is negative 7, right? And then negative 6.5, negative 6.4, 6.3, 6.1, 6.01, 6.001 and so on. You are going to negative 6 from the left. At that time, this will be negative 6.1, negative 6.001, negative 6.0001. So that value will be negative, right? But when you get very close, this will be almost 0, but negative side, right? So 9 over, negative 9 over 0, you can think that way. So it is negative infinity. So basically, this will equals to 36 minus infinity. So this is negative infinity. When you go from the left, it will be, the left limit will be negative infinity for this problem. You understand that?